And we can also write this in an even simpler form, which is what's called electron configuration. And this is just a shorthand notation for these electron wave functions. So for example, again, we see hydrogen is 1s1. Helium, we say, is 1s2 or 1s squared. So instead of writing out the 1s1 and the 1s2, we just combine it as 1s squared. Lithium is 1s2, 2s1. So writing out electron configurations, I realize, is something that a lot of you have experience with in high school. Many of you are very comfortable doing it, especially for the more straightforward atoms. But what's neat to kind of think about is, if you think about what a question might have been in high school, which is, please write the electron configuration for lithium, now we can also answer what sounds like a much more impressive and a much more complicated question, which would be, write the shorthand notation for the one electron orbital approximation to solve the Schrodinger equation for lithium. So essentially, that is the exact same thing. The electron configuration, all it is the shorthand notation for that one electron approximation for the Schrodinger equation for lithium. So if you're hanging your exam from high school on the fridge and you want to make it look more impressive, you could just rewrite the question as that, and essentially you're answering the same thing. But now, hopefully, we understand where that comes from, why it is that we use this shorthand notation. So let's write this one electron orbital approximation for beryllium. That sounds like a pretty complicated question, but hopefully we know that it's not at all. It's just 1s2 and then 2s2. And we can go on and on down the table. So for example, for boron, now we're dealing with 1s2, then 2s2, and now we have to move into the p orbital, so we go to 2p1. So that's a little bit of an introduction into electron configuration. We'll get into some spots where it gets a little trickier, a little bit more complicated later in class.